In this second video, we're going to talk about a couple of questions that might have come up as you start to think about and work with class data types. So one of the questions that might have come up is, what if there is no reference? Like, for example, what if we created a string variable called word, but we haven't actually set it equal to something? Well, then what memory address is word holding? So in this case, Java has a special value that is stored in word, and that's the word null. Because what null basically means is this location is supposed to hold a memory address, but it doesn't have anything there yet. So we haven't created the memory address, we haven't created an object or a place for this to point to yet. But for now, we're just going to have the null placeholder there, which means no reference. So along with that, there's a concept with strings that's important to bring up, which is that strings are immutable. And immutable is just a fancy long word that essentially means you cannot change them without moving to a new memory location. And Java will do this automatically for you. So in this example here, when we create word 1, it points to a memory location that has the word he in it. And then in our second line here, we set word 1 equal to word 1 plus LLO. So you might think that we would just add LLO onto this location here. The thing is that the way Java's optimized, there could be in your memory some int stored right here. Because Java is trying to basically consolidate its memory into your computer's memory storage in the most efficient way possible. And so Java's not going to necessarily have the space to just add on new characters here. So instead what happens is when you do this, instead of changing the string, because strings are immutable, we're going to lose this reference. And now word 1 will point to a new location where Java has found the space to store the entire word hello. So this is important to remember because not all class data types are immutable, and sometimes this is a special case for strings that might be tested on the AP exam. And so you want to start to remember and be comfortable with this idea that strings are going to be immutable data types. So let's have a look at an example to test your understanding of immutable data types. Take a minute to read through this code and see if you can predict what will happen. You create a string called alpha, set it equal to the final frontier. Then you create a string beta, which gets set equal to alpha. So now if you're following along with your memory addresses or references, then beta and alpha should be pointing to the same location. And then we set alpha equal to alpha plus 2. Well, there's a little space in there so that we can now have the final frontier to the sequel. I don't think there actually was a sequel, but we'll just pretend that there was. And then we're going to print out both alpha and beta. And so the question I want you to think about here is, what is going on with the memory addresses of alpha and beta, and what do you think is going to be output? So if you want to pause the video and take some time to think about it, make your prediction, and then come back. All right, so now that you have your prediction, here's the output from our code. We're going to have the final frontier 2 printed out first, because that's what alpha holds, and then the final frontier without the 2 printed out, because beta was still pointing to the original memory location where we created the final frontier string. Okay, at this point, you should have the skills you need to take on the coding challenges for this lesson. Good luck, and I look forward to going over more different class data types and working with them throughout this unit.